Okay, AP Physics, this is our last summer lesson, number 16. It's on circular motion. So what is circular motion? So when an object moves in a circle, there are two components, parts of its force. The centripetal force is the force holding the object in the circle, pointing towards the center of the circle. The tangential force that is perpendicular to the centripetal force is a tangent line, and that line touches the circle in exactly one place. And that's what causes the object at any point to move sideways. So one force is holding it in, one force is moving it sideways, and those two together, if you take the resultant vector of any of those two vectors, you'll end up with the shape of a circle. Now there's another type of force you might have heard of called centrifugal force. That's really not a real force. It's just kind of an imaginary force that's pushing the object outward, but it's not an actual force in physics. So when an object moves in a circle at a constant speed, its direction is changing all the time. So its velocity is changing all the time, even though the speed stays constant. The changing velocity means that the object moving in a circle is accelerating all the time. So the ball moving in a circle moves forward because of the tangential force and stays in the circle because of the centripetal force. If a rope breaks at point A, then the ball continues along the tangent where the rope broke because there only a tangential force and no centripetal force is acting on the ball. So if you swing an object on a string around and then release it, this eliminates the centripetal force and leaves only the tangential force. This means that the object flies away in a straight line along the tangent where it was released. Now it might curve down to the ground because of gravity, but aside from that, it's going to move in a straight line. It's not going to curve away from that circle or towards that circle. It's going to move straight directly to the right in a straight line. What is angular acceleration? Acceleration is not only a change in speed, but also a change in direction. Acceleration due to a change in direction is called angular acceleration. The formula for acceleration caused by a change in direction is A equals vi squared, and the v in this case is the tangential velocity, over r, which is the radius, the distance from the center of the circle to the object. So r is the radius of the circle, vi is the tangential velocity. So example, Wolf Boy is swinging a 3-kilogram block, and you can imagine really that you're looking down on him, that he's swinging it around in a circle parallel to the ground and you're looking down on him. So he's swinging a 3-kilogram block that is moving in a circle on a 2-meter rope with a tangential velocity of 4 meters per second. What is the acceleration of the block? So you simply take the 4 meters per second, you square it, you get 16. The radius is 2, so that means the acceleration is 8 meters per second squared on that block. Even though its speed is staying the same, it is accelerating at 8 meters per second squared. Since F equals ma, the force on the rope is given by F equals m times the angular acceleration, which is v squared over r. So r is the radius of the circle, vi is the tangential velocity, and m is the mass of the object at the end of the rope. So what is the force on the rope if Wolf Boy swings a 3-kilogram block in a circular path at 4 meters per second at a radius of 2 meters? So the acceleration is going to be the same. That's going to give you 8 meters per second squared, and now you multiply that by the mass of the block, 3 kilograms, and that will give you 24 newtons. So 24 newtons is the force on the rope, it's the force on the box, and it's the force on Wolf Boy's arms. They all have a force, or exerting a force of 24 newtons. And that takes care of our brief lesson on circular motion. Circular and rotational motion are going to be two of the tougher subjects in this class because they're not quite as intuitive as linear straight line motion in your everyday life. So we'll spend a lot of time working on those. And that concludes our summer program, and I'll look forward to seeing you in class.